In the previous session, we talked about quantitative and qualitative research paradigms and the binary distinction of quantitative and qualitative research. We also talked about different design types of quantitative research. We said that we have two major quantitative design types, namely experimental and non-experimental designs. And we talked about experimental designs. We said that we have three experimental designs, one of which was true experimental design or true randomized experimental design, and the other one was quasi-experimental design. This session we're going to talk about pre-experimental design under experimental designs, and also we will talk about different non-experimental designs. We can categorize pre-experimental designs into three types. First is single group or one-shot design. Second is one group pre-test post-test design. And the last one is intact group design. The first one is single group one-shot design. In this design, we have only one group, which is the experimental group. Afterwards, they receive the treatment, and then after the treatment, we can administer the post-test. So as you can see here, there is no control group, and all of the participants are given some experimental instruction, and then they receive a post-test. And also, the results of such a study are neither valid nor generalizable because the researcher just looks at how well everyone did at the end. Though the findings of this study enjoy low validity, they can be used for further research. But the point is that we don't have any control group and it is a single group design. This is why we mentioned that it enjoys low validity. As we said before, the second type of pre-experimental design is one group pre-test post-test design. There is one experimental group together with pre-test. Afterwards, we have a treatment, and finally the post-test. So a pre-test is given before the treatment, and there are two tests. This design is similar to the single group design, but with a pre-test conducted. A group is measured on the independent variable at first, which is pre-testing, then they receive the treatment, and in the final stage a post-test is taken after the treatment. Then results of the pre-test and the post-test are compared to see if the hoped for change has occurred. The design is an improvement over the one-shot case study because you have measured the gains that the subjects have made rather than just looking at how well everyone did at the end. However, interpreting the pre-test and post-test difference should be done with caution, since you cannot be sure that the differences in the pre-test and post-test are casually related to the treatment. It can be related to something else. The third pre-experimental design is intact group design. And this design is just like the previous one group pre-test post-test design. As you can see, we have an experimental group together with pre-test, then treatment, and finally the post-test. But here the difference is that the experimental group is one intact class. That is, the students in one class is considered as one group, which is the experimental group. This is why we call it intact group design. and the researcher selects participants from classes on the basis of some criterion. For example, their scores on a placement test or successful completion of the prior course. And in order to compensate for random assignment, because as I said, in intact group, you can only assign one group. In fact, one class as one group, which is the experimental group, and you cannot randomly assign the students. You can just randomly assign the classes as the groups. So the researcher should randomly assign the class as one intact group. This also helps with the external validity of this type of design. In fact, most outcomes in research are likely to have several causes that interact with each other in a variety of ways that cannot be identified through the use of two-group or one-group experimental designs. Therefore, we use factorial designs. Such designs can be located both in experimental and non-experimental research. They, in fact, enable us to empirically examine the effects of more than one independent variable, both individually, that is one independent variable, and in combination, that is more than one independent variable, on the dependent variable. In fact, the factorial design has several important strengths. First, it permits the simultaneous examination of more than one independent variable. Second, the factorial design allows us to test several hypotheses in a single research study. It can be more economical to use a factorial design than to conduct several individual studies in terms of both number of participants and the researcher effort. And finally, the factorial design allows us to look for interactions between independent variables. A factorial design involves more than one independent variable, as you can see, and can occur with or without randomization. A factorial design, in fact, allows the researcher to consider more than one independent variable, and generally we call it moderator variable. You can see the fourth chapter in Tawakkoli book for a discussion on variables to see the difference between moderator variable, mediator variable, and also dependent and independent variables. When reviewing the results of a factorial study, we begin by determining whether there are any significant interactions between the independent variables. Look at this example. The effects of individual and collaborative planning on fluency, complexity, and accuracy, CAF, in L2 written production of Iranian EFL learners, focusing on planned conditions, language proficiency, and task type. Here, the first research question can be the effect of these two planning types on CAF. That is the main effect. The effect of planning, these two types of plannings on CAF. The second research question can be the effect of task type on CAF. For example, we have two different task types and we want to see the effects on CAF, on complexity, fluency, and accuracy of students' writings. But here we can also investigate a third research question to see the interaction effect, to see if students' plannings, different plannings, conditions like individual and collaborative planning, to see if we can find any differences between individual and collaborative planning groups differ with regard to their proficiency levels. That is to see if this pattern is the same for example, all three proficiency groups. Here we are investigating the interaction between the independent variables. That is, we want to see the interaction between plant condition and language proficiency. Sometimes we can also include the third variable. Here it is task type. We can see if task type play any role in the pattern that students have in planning conditions, in the two planning conditions. Here, as you can see, we are dealing with a kind of interaction between the independent variables. This is why we call it factorial design. Having talked about different types of experimental design, we need to address a basic issue in research, which is the quality criteria. By quality of research here, we refer to the validity of the research project. Validity has to do with the extent to which a piece of research actually investigates what the research purports to investigate. Its primary purpose is to increase the accuracy and usefulness of findings by eliminating or controlling as many confounding variables as possible, which allows for greater confidence in the findings of a given study. This is why we say it is related to the quality of our research. There are two distinct types of validity, namely internal validity and external validity. These two interact to control for and minimize the impact of a wide variety of extraneous factors. In fact, we draw a distinction between two types of validities, internal and external validity. Internal validity refers to the soundness of research, and external validity concerns the generalizability of the results. So, the internal validity is the degree or extent to which the differences in the dependent variable are due to experimental manipulation and not some extraneous variable. This is the internal validity. Internal validity means the validity of the inferences about whether the effect of variable A, which is the treatment, on variable B, which is the outcome, reflects a causal relationship. In fact, in internal validity, a researcher must control for all other possible factors that could potentially account for the results. For example, if we wanted to observe reaction times to a set of grammatical and ungrammatical sentences, we might devise, for example, a computer program that presents sentences on a computer screen one at a time, with learners responding to acceptability or unacceptability of each sentence by pressing a button on the computer. Now, maybe one says that students' left-handedness or right-handedness, this can affect the results of our study. If this affects the result of our study, we can say that, yes, this fact threatens the internal validity of our research. In fact, there are some factors that can be considered as threats to the internal validity. History is the first one. Unplanned events other than the treatment that concurrently occur and affect the dependent variable. This is the meaning of history. How can we control it? We can, for example, select an appropriate control group. The second one is maturation, psychological or physiological changes that occur within participants. For example, some participants may grow older or they may become more experienced, etc. Again, we can control it by choosing an appropriate control group. Another threat can be testing. taking a test generally affects subsequent testing, which is practice effect. How can we do it? We can extend the gap, the time between pre-testing and post-testing, or we can again consider an appropriate control group in order to take care of this threat. We may see these mainly in studies with repeated measures or a pre-test post-test design. Next threat is related to instrumentation, that is the lack of reliability or validity of the instruments. And we can take care of this issue by applying reliable and valid instruments or training our observers and using short observations, things like that, in order to have valid and reliable instruments in our study. The other threat can be regression. That is, individuals' high or low scorings on pretest due to some factors tend to regress towards the mean during retesting. Again, we can control this by an appropriate control group. We may find this threat in pretest post-test designs. That is, a student's scores may be different a lot. And next is participant selection. Pre-existing differences between the participants can be another threat to the internal validity of our research. We can randomly select the participants, or we can use pre-testing. That is, we pre-test the participants to ensure their homogeneity in order to take care of this threat. External validity is the degree to which research results generalize to other conditions, to other participants, other times, and other places. In fact, the extent to which the results can be generalized from sample statistics to population parameters. This is the definition of external validity. With external validity, therefore, we are concerned with the generalizability of our findings, or in other words, the extent to which the findings of the study are relevant, not only to the research population, but also to the wider population of language learners. External validity means the validity of the inference about whether the cause-effect relationship holds up with other subjects, settings, and measurements. It is important to remember that a prerequisite of external validity is internal validity. If a study is not conducted with careful attention to internal validity, it clearly does not make sense to try to generalize the findings to a larger population. In the second part of this session, I'm going to talk about non-experimental designs. Up to now, we talked about experimental designs and pre-experimental designs, and now we're going to talk about non-experimental designs. Non-experimental designs are most similar to experimental designs, but they do not involve a manipulation of the situation, circumstances, or experiences of the participants. This is why we call it non-experimental design. In fact, we have no experiments. We do not manipulate the independent variable. There are 5 different types of non-experimental designs. The first is causal-comparative design. Second is correlational design. Third is descriptive design. Fourth is survey design. And the last one is field design or field research. I'm going to talk about each of these one by one. The first type of non-experimental design is causal comparative design. Like experimental design, this design involves comparing groups to see if there is a causal relation among the variables. There is no treatment and it aims at causal relation. Causal comparative research attempts to, in fact, identify a causal relationship between two or more groups and determines reasons or causes for the existing condition. Because the condition is existing, it is also referred to as ex post facto design. Ex post facto is Latin for after the fact. Why? Since both the effect and the cause have already occurred and must be studied in retrospect. Because both of them had occurred and finished, we call it ex post facto design. Causal comparative design has the following goals. First is to show causal relationships clearly. Second is to investigate factors which produce the causal condition. And finally, the goal is not to manipulate the cause or independent variable as in experimental research. In experimental research, we change something in the experimental group. We change or manipulate the independent variable in order to see the cause. But in non-experimental research, and specifically speaking in causal comparative research, we do not manipulate anything. We just want to investigate the factors which produce the cause. This is why we call it non-experimental research and causal comparative design. Here is an example for a causal comparative design. Suppose that we want to investigate the effect of a student's anxiety on their performance on an achievement test. First thing to do is the division of the participants into two groups, high and low anxious groups. We can do it by administering an anxiety scale and then dividing students to high and low anxiety groups. And then we give the achievement test to both groups. An achievement test can be something like an English proficiency test. We administer the test to both groups, high and low anxiety group, and then further we investigate the difference between the two groups. This way we can see, for example, if a low anxiety group outperform the high anxiety group in the achievement test, the temptation would be to conclude that anxiety has a negative effect on students' achievement, for example. In fact, because of lack of random assignment, manipulation and control over extraneous variables, care should be taken in generalizing the results. As you see in this example, we didn't manipulate anything. We just in fact grouped the students based on their anxiety levels, and we just investigated the differences between the two groups with regard to the participants' performance on the achievement test, and we didn't manipulate anything. We didn't control anything. Therefore, care should be taken in generalizing the results. But in fact, we can say that causal comparative design has a number of merits. One is that this design allows investigation of variables that cannot be investigated experimentally, something like anxiety. You cannot manipulate the student's anxiety. You cannot make it higher or lower. Yes. The second positive point about causal comparative design is that it facilitates decision making, and also it provides guidance for experimental studies, and it is less costly on all dimensions. Now, what do I mean by providing guidance for experimental studies? That is, first, before spending a lot of money, before doing a lot of experiments, you can check if there is any effect at all by doing a causal comparative design. And then if you see that there is a kind of effect, for further research, we can, for example, spend a lot of money, use grants, do experimental studies, and then find generalizable, or let's say more generalizable research findings. The second type of non-experimental research design is correlational designs. The most useful applications of correlation are assessing relationships, assessing consistency, and making prediction. In fact, correlational research is used for relating variables or predicting the outcomes. Researchers measure two or more variables and examine the degree of the relationship among the variables. For example, student motivation and their achievement score. And the research question would be, is there any significant relationship between students' motivation and their achievement score? Or we can state other examples. Is there a relationship between the number of teacher absences and students' test scores? Is there any relationship between performance on measures of L2 grammatical knowledge and learners' motivation? Or another example can be, is there any relationship between performance on measures of L2 grammatical knowledge and learners' anxiety rates? These are all examples of relationship questions. In fact, the degree of relationship is expressed as a correlation coefficient. And they are classified as positive correlation or negative correlation, and also tend to show strong and weak relationships. And we have different indexes for correlation coefficient. It can be started from -1 to 0 to +1. If the variables are highly related, a correlation coefficient near +1 will be obtained, meaning the variables are positively correlated. Here, the strength of the relationship is too much. The correlation coefficient, in fact, is perfect. +1 never happens in reality, in fact. Maybe we can say that correlation coefficient indexes higher than 0.7 or 0.75 can be considered as strong relationships. However, if the two variables are not related, a correlation coefficient near 0 will be obtained. Usually, correlation coefficients below 0.3 are considered as very low, or in fact no correlations. And if the correlation coefficient is near -1, then again the strength of the relationship is very much. But in fact, we can classify it as a negative correlation. So we can say that the variables are inversely related. In the example we have about students' motivation and their achievement score, if there is a positive relationship, we can say the higher the student's motivation, the higher their achievement score. But if we have a negative relationship, we say the higher the student's motivation, the lower their achievement scores. This is the meaning of negative correlation. In fact, unlike causal comparative designs, in correlation designs, we do not show causal relation. Correlational research is more likely to explore relationships among variables that are continuous, in fact. So there is a major difference between causal comparative and correlational design. The other type of correlational design is called prediction study. In predictional studies, the goal is to identify one or more variables that can predict changes in another variable measured at a later point in time. Like relationship studies, prediction studies examine correlations between variables. But here, the goal is to identify the ability to predict. In fact, correlations are computed between the predictor variable and the criterion variable. If a strong relationship exists between a predictor variable and a criterion variable, then the predictor variable can be used to make predictions regarding the criterion variable. Look at this example. Can affix knowledge predict EFL learners' performance on vocabulary tests? Here we have two variables. One is students' affix knowledge, and the other one is their vocabulary knowledge. Here we have learners' performance on vocabulary test. So we have two variables. The predictor variable is affix knowledge, criterion variable is vocabulary test. So here, if the result of the correlation between affix knowledge and the vocabulary test is a strong positive one, we can say that yes, affix knowledge can predict learners' knowledge of vocabulary. And that is, if they have enough affix knowledge, we can say that yes, they will have good vocabulary or enough vocabulary knowledge. This is the meaning of prediction. But we need to pay attention to a couple of points here. First, commonly used data sources include test scores, dichotomies, and ranking of attributes. These are the commonly used data sources for prediction studies. And second, samples in correlational research should at least consist of 30 individuals, not smaller than that. Whenever you want to run a correlation in prediction studies, you need to have at least 30 participants in each of the groups. In fact, predictions are dependent on the outcome of a strong relationship between or among the variables. That is, if variables are strongly related, we can often predict the likelihood of the presence of one from the presence of the other. Like in the example, we can predict the likelihood of the presence of vocabulary tests from the presence of their vocabulary knowledge from the presence of their affix knowledge. This is the meaning of prediction study. Descriptive research is another type of non-experimental research. Descriptive research best describes the way things are. In fact, its primary purpose is to analyze trends that are developing as well as current situations. And also, the other purpose is to solve present day problems. In fact, descriptive research is used to obtain information regarding the current status of a phenomenon, or to describe persons, to describe conditions, events, and settings, for example. It often involves collecting information through data reviews, surveys, interviews, and observations. For example, a study conducted to a random sample of Farsi EFL learners in order to describe strategies used by Iranian EFL learners. As you can see here, we do not manipulate anything because it is a non-experimental research. And the point is to describe or in fact find or investigate the strategies that EFL learners use. We don't want to change anything. We just want to, in fact, describe or obtain information regarding the current status of this phenomenon. of this phenomena. What is the phenomena? For example, here we have strategies used by Iranian EFL learners. We just want to obtain information regarding it and then report it in our study. This is one example of descriptive design. And for the analysis, we usually use frequencies, percentage, average, graphs, and sometimes variability and correlations for the analysis, and the interpretation of the data. And sources of the data are numerous in descriptive methods. For example, they can include surveys, case studies, comparative studies, document analysis, trend studies, and etc. etc. Survey research is another type of non-experimental design, which is just like descriptive research design. Investigators use a survey study to describe the attitudes, opinions, behaviors, or characteristics of the population. Survey studies assess the characteristics of a sample or whole population of people or situations. In fact, participants are asked to complete a questionnaire or interview in a natural setting. Survey research is typically conducted through 4 or 5 different ways. For example, through telephone, mail, email. It can be online or in person, or it can be offline, for example, like filling out a questionnaire. Survey studies can only establish associations and suggest causal linkage, but they cannot establish causal relationships. See, they can only establish associations and suggest that there would be a causal linkage, but they themselves cannot establish causal relationships. For example, we can compare various types of schools. For instance, single gender versus co-educational schools, in order to assess the relationship between the gender composition of schools and the students' educational, for example, achievements. This is a type of survey. In survey, quantitative data are usually collected through several procedures. And again, like in descriptive research, we use percentage, frequencies, and things like that. And in survey studies, we can also have comparisons. For example, comparison of the performance of students at various ages, at various grades, at various, for example, genders, or at various nations. This is one use of survey research. The last type of non-experimental research is called field research. It is properly understood as a kind of ethnography. In fact, the investigator makes an attempt to gather data from people in naturally occurring settings or fields in order to capture their social meanings and ordinary activities. This is why we call it field research, because it is something that happens in the field. You, as the researcher, should enter the field and try, or we can say, start gathering information. In fact, the researcher is directly involved with participating in the setting in order to collect data in a systematic way. But the researcher does not allow external meaning to be imposed on the obtained information. That is, your own taste, your own attitude should not be included while you are collecting the data. Why? Because it becomes bias. In fact, field research can be very exciting, and also it can be a rewarding experience, leading to important discoveries and breaking through the ideas. In fact, its goal is the same as research done in the library, that is, to gather information to help you to understand an issue or to find an answer to a question. But instead of library and reading books, you are in the field and you are observing the reality. This is what we mean by field research. We started this session by introducing pre-experimental designs, and we said that we have three types of pre-experimental designs. Then we talked about factorial designs and also validity. We said that there are two types of validities, internal and external validity. Afterwards, we started the discussion on non-experimental designs, and we said that we have five different design types under non-experimental designs, namely causal-comparative, correlational, descriptive, and survey, and finally field research. This is the end of the eighth session. Goodbye and good luck, everybody.